Hello everyone, this is part 5 video. In this video, we are going to discuss 3 programs based on the nested for loop. Program number in this series is a 12th program, display prime numbers between the two bound, upper bound and lower bound. Next, printing the table chart using nested loop. And finally, the star pattern. Okay. First program in this video, printing a prime number between the two bound. So lower bound and upper bound. So we need two variables, namely A and B. First, we'll receive input for both the ranges. Enter lower and upper bound. Means it may be between 10 to 100. Example, I'm telling. Percentage D. Ampersand B. Right. We received both lower and upper bound. With this bound, we need to find or we need to display all the possible prime numbers in the screen. Okay. We already know how to find a particular number is prime or not using number of factors. If number of factor is 0, then we can tell that particular input or number is prime number. Here, we need to go for nested loop. What is meant by nested loop? One loop is completely inside the another master loop. Here I am writing the outer loop. I am starting from A is equal to I is equal to A. What is A? Lower bound. Let's say here after in this program, I'll say lower bound as, for example, 10 I'll take. Upper bound, I'll take it as 100. Okay, right. I less than B. What is B? 100. I plus plus. That's it. We have done with the outer loop. What is the purpose of outer loop here? Means line number 7, we have written one loop, right? What is the purpose? Just we are traversing from the lower end to the upper end. From 10, 11, 12, keep going till the 99. Okay. Next. Now we are going to find hereafter our input is only one number. As of now, the first iteration, I value is 10. As per our example, I value is 10. So our input 10 is prime or not. That we have to decide. If it is prime, then we'll print there. Or else, we'll think about the next number, 11. After deciding about the 11, we'll think about the 12. Like that, we'll keep going. Okay, right. Integer j is equal to 2. Why I'm starting from 2? The reason I should not start from either 0 or 1. The reason, if I'm starting from 1, definitely all 1 divides any number. That is the reason we supposed to start from where? 2. J less than I value. I value is 10. Again, I'm telling here as of now. J plus plus. So what I'm going to try? I'm going to try for counting the number of factors for 10. So I'll check whether 2 is dividing the 10 or not, 3 is dividing 10 or not, 4 is dividing 10 or not, like that. Okay, right. How do I check? If condition, if I, that is input here, is modular division by j. What is j value? 2, 3, 4, 5 is equal to 0 or not. If it is properly divided, we'll go for counting it. C is equal to C plus 1. For this, initially, must declare the C value, right? Actually, we have in the line number 13, we have expression C is equal to C plus 1. As of now, what is the value of C? Not mentioned, right? So we have to keep some value for C. Only then it makes sense. When without a value, how do you go for arithmetic operation of addition there? So C must be initialized with 0. That too, we should not give just outside the outer loop. I value is equal to 10. Right? Right. Then after getting inside, now C value 0. Now again, J value 2. Like that. Okay. Right. Now, I value is 10. 10 modulo division by 2 is equal to 0. Condition true. Yes. Condition true. Condition true means C is equal to C plus 1. Then C will become 1. So, based on the C value only, we are going to decide a factor or not a factor. Based on the C value only, we are going to decide a prime or composite number. So if already I explained it clearly, if C value is equal to 0 means then we can come to the decision or we can print that number in the screen. That number is what? I. Suppose here coming to that I is equal to 10, this is actually a composite number. So C value will be upgraded to 1. While coming to the next conditions, maybe I takes a value 11 now. Again, C value we have to start from 0. Strictly, we have to start the number of factor from the 0 since our input has been changed now, right? That is the reason I made a C is equal to 0 in the line number 10. It should not be a just here. Okay, fine. I hope you all understand this. If you are not understand, you can hear this once again. Right. I'll run this program now. Lower bound is 10, upper bound is 100. We got the answer. We'll make it as some small gap in the print statement. Yes, 11, 13, 17, 19. These are the prime numbers between 10 and 100. I hope it is understood clearly, correct? I will keep this in the screen for some time. You can make a note of this. Next program. Display table chart. For example, here we don't want to go for any input and all. We are interested to print the table from 1 to 10. In the first row, 1, 2, 3, 4, 5, 6, like that. In the second row, 2 tables, 2, 4, 6, 8, 10. And third line, third table. Tables of 3, 3, 6, 9, 12. Okay, right. How many lines involved here? 10 lines. How many columns involved? Again 10 columns. Like that, in a grid manner, we like to print tables. So again, we need to go for nested loop here. So I is equal to, I'll start from 1. The reason we are interested to print from the table number 1. So I less than or equal to 10. I plus plus. Okay, right. What is the purpose of outer loop here? This is just to traverse from 1 to 10. Okay, right. Here inside, again, I'm going for writing one more loop here. Integer j is equal to, again, I'm starting from 1. J less than or equal to 10 again. So j plus plus. Now tell me total number of iteration. Can anyone tell the total number of iteration of this whole program? 100 number of iteration. How it is happening? Outer loop runs for 10 times. Inner loop runs for 10 times again. So one iteration of outer loop, it is 10 times in inner. So 10 into 10, 100 times it is running. So 100 elements will be displaying in the screen. But in the line number 1, only 10 elements we need. So here inside, we are going to keep a print statement that is the product of I into j. What is I value here? So I value is equal to 1. But here, j value is equal to 1, 2, 3, 4 till 10. For I is equal to 1, j runs for 10 number of times. This is the meaning of nested loop. So 1 into 1, 1 into 2, 1 into 3, like that we have to print in a same line. So I'll make it as like this. Right. So after printing the one line, it is good to have our cursor to the next line. Means one line means here outside the inner loop. I'll make it as a new line. Okay, right. That's it. We'll see the output now. Yes. Yes, we got it answer. Correct. First line, it is one table. This is second table and third table like this. 10th table, 10, 12, 30 till 100 we have printed. Actually, it is aligned properly one day. See, some numbers are in single digits, some numbers are in 2 digits. So it is like, look like this. Next program, printing star pattern using nested for loop. Okay. Actually, I need to tell one important things. It is not even printed in any books clearly. In the nested loop, we have two types. Number one, dependent loop. Dependent loop. Number two, it is independent loop. Independent loop. Independent loop. Right? What is maybe dependent loop that we are going to see now? See, dependent loop means inner loop iteration or steps depends on outer loop value. Okay, depends on outer loop value, right? Whereas here independent loop, there is no connections between outer and inner loops. Inner loops runs for constant number of times for the each and every outer loop. Okay, right. So we have seen a two program as of now in this video. In the two programs, we have seen independent loop. Okay, right. See, j number of iteration does not have any impact due to the outer loop I value. This is how we have seen as of now. Understood, right? But this program, it is dependent loop. The meaning, inner loop iteration purely depends upon the outer loop value. You come to know after writing the example, okay? Right. Here we'll have some input, deciding the number of rows. I'm scanning this. For I integer, I is equal to, I'll start from 1, 1, I less than or equal to A, right? What is A? Input, deciding number of rows. Okay, right. Integer J is equal to 1, J is less than I value or equal to I value. Here, nested loop again. This is I loop, outer loop, and this is J loop, inner loop, right? Here, look at the condition. J is less than or equal to I. So here, J loop runs how many number of times? It is not a constant. It purely decided based on the value of I. So it is depends upon the I. So it is a dependent loop. Okay. Why I'm making this like this? Actually, we are expecting to print like star in first line, star, two star in second line, 3 star in third line. Like this, we are trying to print. So in the first time, only 1 star printed. The second line, 2 star printed. Next, 3 star have been printed. So some printf statement have been executed only one time. Here, printf statement have been executed 2 number of times. So number of iteration is getting different over the outer loop iteration. That is the reason we are preferring dependent loop. Okay, right. In simply, I can tell you one more thing. Outer loop purpose is deciding the number of rows, whereas inner loop decides number of star to be printed in one line. Here, I am printing the star. Okay, right. After printing the star, we have to bring the cursor to the next line when after printing all the required star in one line. That's it. Now we'll run this program. No, it is wrong. Actually, it is less. There's a small problem. It is actually J++. Yes, we got the answer correct. Ah. That's it. Thank you for watching. Stay tuned for the next video. Thank you all.